Welcome to The Explainer. You know, in the world of AI, we're always searching for these incredibly complex, mind-bending solutions. But what if one of the biggest breakthroughs came from an idea that was just simple? Well, that's exactly the story we're diving into today.
So think about this for a second. How do you actually get a machine to understand an image the way you and I do? This single question is kind of the holy grail of computer vision. And for years, it drove this fierce annual competition where the brightest minds on the planet battled to build the smartest artificial eye.
And that competition was the ImageNet Challenge. Seriously, you can just think of it as the Olympics for AI vision. The task? Build a network that could look at millions of images and correctly identify thousands of different things, from cats and dogs to different kinds of cars. It was the ultimate proving ground.
By 2014, things were getting intense. Researchers were tweaking every knob they could find, fiddling with different training methods, making the architectures more and more complicated, basically throwing the whole kitchen sink at the problem. But one team from Oxford, the Visual Geometry Group, or VGG for short, decided to tune out all that noise and focus on one simple variable.
So, what was this big idea? Well, the VGG team asked this powerful, almost deceptively simple question. What if we stop trying to make things more complicated? What if we hold everything else the same and just go deeper? What if the secret wasn't complexity at all, but just more layers?
See, at the time, everyone was using these big, clunky filters, like a giant 7x7 pixel window, to try and capture complex patterns all in one go. But VGG's hypothesis was totally radical. They thought, or what if we just use a whole bunch of tiny, simple 3x3 filters stacked one on top of the other? And that simple idea, well, that was the whole game changer. It all came down to using these tiny filters, like Lego bricks, to build something much more powerful. Okay, so before we get into the genius of it, let's just do a super quick refresh on what a filter even is. Think of it like a tiny detective that's trained to look for just one specific clue. Maybe it's a straight edge, or the color red, or a corner. The network is just a huge team of these little detectives all working together.
Okay, so this is the magic right here. That big 7x7 filter, it gets one look at a part of the image, one shot to make a decision. But if you stack 3 of VGG's tiny 3x3 filters, they cover the exact same area, but get to make 3 separate decisions along the way. It gives the network more chances to learn. And here's the kicker. It was actually more efficient, using fewer parameters to do it.
And hey, don't just take my word for it. The researchers themselves said it perfectly. By stocking the filters, they made the decision function more discriminative. That's just a fancy way of saying they build a smarter network, one that could tell the difference between things with much greater nuance.
So, it all sounds great in theory, right? It's elegant, it makes sense, but the real question, the only question that matters in a competition is, did it actually work?
Oh, it worked. The proof was right there in the numbers. As they kept stacking more layers, going from a 16-layer model all the way up to a 19-layer beast, the error rate, basically the number of mistakes the network made, just kept dropping. The trend was undeniable. Deeper meant smarter.
And you have to understand, this wasn't just a small improvement. This was a giant leap. Just 2 years before, the best model in the world had an error rate over 16%. The year before, it was nearly 12%. VGG wasn't just inching forward, they were about to rewrite what was even considered possible.
And there it is, 6.8%. Now technically, this result landed them in second place that year, but honestly, the place on the podium didn't matter. What mattered was that their go-deep philosophy had just proven itself in spectacular fashion. They showed everyone the path forward.
And that's really why we're still talking about VGG today. Its impact wasn't about one competition. They established a brand new rule in the AI playbook. When in doubt, go deeper. Depth became the new standard.
And here's the other amazing part. They didn't just set a new record and walk away. They gave their work to the world. Their network became the new yardstick. If you were building a vision model, you had to be better than VGG. And because they shared their models, research just exploded. Suddenly, this architecture was being used for, well, everything, from object detection in cars to automatically writing captions for your photos. In their final paper, their conclusion is so beautifully simple and confident. They just stated as a fact. They confirmed the importance of depth. They proved beyond a shadow of a doubt that to teach a machine to truly see, you have to let it look at the world through many, many layers.
So in the end, one of the biggest leaps in AI history didn't come from a wildly complex new algorithm.
It came from systematically exploring a simple foundational idea. Just go deeper. And that just makes you wonder, right? What other elegant, simple ideas are just sitting out there waiting to be discovered?